Hi, this is Scott. I really appreciate our sponsors because they make the show possible. Today's show is sponsored by Developer Express. Become a UI superhero with Dev Express controls and libraries. Deliver elegant .NET solutions that address customer needs today. By leveraging your existing knowledge, you can build next-generation touch-enabled solutions for tomorrow. You can download your free 30-day trial at dx.hanselminutes.com. That's dx.hanselminutes.com.
From hanselminutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 502. In this episode, Scott talks with Julius Sweetland about OptiKey, a program designed to provide keyboard control, mouse control, and speech to people with motor and speech limitations.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. Today I'm talking with Julius Sweetland. He is the author of OptiKey, and this blew up the internet a couple of weeks ago and is a really, really exciting example of what the power of open source can do. How are you, sir?
I'm very well, Scott. How are you?
I'm brilliant, and I'm very excited to talk to you. You kind of released onto the world OptiKey, but it's clear you've been working on this for, what, near a year?
No, much longer. Nearly 4 years, I think.
Really? Wow. How did you was it happening in public? Because it seemed like when you released it, it got on Hacker News, it got on Reddit, it made quite the splash.
Yeah, that was the very last thing I did. So it started, like I say, about 4 years ago, and it was originally not on GitHub, not on anything on the internet. It was buried on my computer and backed up to Dropbox, which is a terrible idea. and then when I felt it was sort of ready and going from prototype 1 to prototype 2 and feeling a little bit more rounded and full, it finally got itself onto GitHub. And then another year or so passed, and eventually I got the courage to put it out there, and I posted something on Reddit.
Fantastic. So what is it? What is OptiKey, and what problem does it solve?
So OptiKey is a piece of .NET software that I've written. It is designed to allow people to control their computer fully and to speak using only your eyes. So it's really designed to solve the problem where people have motor and or speech limitations. And my target audience is people with motor neuron disease or ALS.
Do you have this problem, or why did you solve this problem?
No, I don't have this, but I had an aunt who died from motor neuron disease a little bit over 4 years ago now. And it was it taught me a few things, and it's my first experience with the disease. And it sort of presented, apart from everything else that was going on, it presented a very difficult technical challenge that I thought I had a chance of doing better than what, the solutions that I could see out there.
It seems like such a insurmountable technical challenge. I mean, when you look out into the software landscape, there's products that cost many, many thousands of dollars. And when I hear about assistive technologies, particularly ones that are doing things like real-time eye tracking, I think, wow, there's probably a whole team of PhDs working on this. Why did you think you had the skills to do that?
Honestly, probably because I didn't know the scale of the problem when I started. Or I was too stupid to appreciate how much time it was going to take me. But I knew at the beginning that an open source or a free solution was a very important thing to attempt. And I sort of saw the end goal before I really understood the scale of the problem. And I sort of got something between my teeth early on and went with it.
I think that's great. I mean, I hope you didn't think I was too cheeky by asking that question, but I think that so often we look at a problem, we go, all right, that's a solvable yet finite, interesting problem I can spend a little time on the weekends working on, and this was quite a bit larger than you thought it would be.
Yeah, it got out of control, but there was also large periods of time where I'd either got frustrated and put the problem down again, or something else had come along and got in the way, and it wasn't a solid 4 years of working on this, and it broke down into other problems that I had to solve. So there's big hardware problems to surmount before you even get onto the software problems.
I think one of the other things that's interesting about a problem like this is that it is somewhat well layered in the sense that there are individual kind of finite modules, like talking to the eye tracking hardware and doing that in a nice layered way. That's a problem. Having a nice assistive on-screen keyboard, that's a problem. It's very layer cake.
Yeah, absolutely. Yeah. I can't really break it down into any sets. There have been thousands of tiny problems to solve. And then every time I solve a handful of them, it's been the problem of putting them back together into a way that makes the solution scalable as I then try and solve the next batch of problems. It's not a foreign problem to a software developer. That's tends to be what we do, but it was just the scale of doing that rinse and repeat, and also the difficulty of not knowing necessarily where I was going with these things. So if I'd have started this project knowing, right, this is the end result and this is what it's going to look like and this is how the solution is going to be laid out, it would have been much easier. But yeah, sadly, real life isn't like that, especially when you don't understand what you're solving most of the time.
Mm-hmm. So it's an assistive on-screen keyboard. It runs on Windows. It's written in .NET. Is this a WPF application?
It is, yeah, which is, it's something I'm very comfortable working with. I like WPF tremendously, but unfortunately, one of the big requests that people have had since I launched it is, can you make it cross-platform? Can I run it on Linux? Can I run it on Mac? And unfortunately, WPF doesn't play very nicely in those arenas. Mm-hmm. So, if I had to do it all over again, maybe I would have chosen differently, but I'm happy with how it turned out.
But isn't there a core engine that isn't UI specific that you could, with the advent of .NET Core being cross-platform, couldn't you write a Cocoa-based front end and have that call into the .NET Core and, share some code?
Yeah, no, absolutely. I mean, one thing that I do want to do at some point is take the project as it is, because it is one project, if you look at it on GitHub, and split it out and say, well, actually, these components make up the idea of input to this system, and these components make up a completely different project, and they handle the concept of output. And it's just that middle bit of how to show the UI and how to do window manipulation. And there's a ton of Win32 API calls and things like that that really I need to take a good hard look at them and go, well, these don't need to be in this technology anymore. Let's do them in something cross-platform. But the one thing that I really don't have is time. And that is a huge problem to solve.
So that sounds to me like a bit of a call for participation from maybe someone who might be listening who could help out.
Yeah, no, absolutely. I mean, that's one of the most exciting things about launching this project. It's been the response of people out there that I didn't know existed coming forward and saying, this is great. Right, here's what I can do. Where do you need me? Mm-hmm. And I didn't expect that at all. And, 2 days ago, I got a pull request on the repository from someone who'd solved the problem of auto-completing words with misspelt characters in it. And it's something I'd put up as an issue on the repo to go back to at some point. But I had no idea someone was even working on it. It's fantastic getting these sort of contributions.
Yeah, it is challenging, though, to manage the influx, though. And it's also interesting to point out the kind of the ratios. If you can imagine, you've got 2,000 or so stars, which are, people expressing their interest and their enthusiasm about the project. You've got 25 issues open, and you've got 2 open pull requests and maybe a total of 30 or so. So it's a bit of a long tail, isn't it, right? 2,000 people express extreme interest, maybe thousands download it, but then a lot of people complain, which are your issues, and then much, much fewer actually contribute code.
That's true, yeah. But what I've been very lucky with is that the people who are contributing to the project are fantastic. Like, you don't get to work with great people in the workplace where everyone is paid to be there and do a good job. So I didn't expect the quality of people where no one's being paid to do this. But then again, maybe I'm thinking about it backward, because what I'm attracting are people who want to be doing this in their free time. And that's where you're going to get quality, isn't it?
Yeah, absolutely. I've found in the open source space, when it comes to really utilitarian software, whether it be utilities that everyone likes, or in this case, assistive technologies, which are by their nature absolutely utilitarian, people are much more excited about helping with these things because it is probably affecting either their life or the life of someone that's close to them.
That's true, yeah. And it does seem to be working. I like I said, I'm attracting excellent people, and I'm thoroughly enjoying working with them at the moment.
But you're still doing this on your own.
I am, yes. It's something I pick up on the bus on the way to work. So I've got myself a little tablet that I hack away on for about 45 minutes. And then when I get home and I've had dinner and I put my son to bed, it gets another hour, maybe 2 if my wife's feeling charitable.
Yeah, it is a challenge when it's not your full-time job. So I would be so bold as to call out to the audience that not only I think is Julius looking for help, but hey, if you are if you're Oprah, if Oprah is listening and you want to sponsor Julius to work on this full-time, I'm sure he would not turn down $1 million.
No, my arms are open. That'd be fantastic.
So let's talk a little bit about the technology here. I've got a number of webcams. They're high-quality HD webcams. Can they track my eyes?
Well, it's not impossible, and there are solutions that are out there, but it's not how the industry solves the problem, and I think that's very telling of where the best solution is. So the way the industry generally solves this is to have a dedicated camera that sits below your screen. It's very much akin to a webcam, but it's specialized in that it will only pick up infrared light. So that's coupled in the same device with infrared light sources. And there are multiple ways to solve this problem, but typically you produce 2 or 3 light sources, and they produce what are called glints on your eyeball. So they don't move. So as your head moves and your eye swivels to look at different parts of the screen, those glints are always in the same spot on your eye. And the camera picks those up. And it picks up your pupil at the same point. So it will detect exactly where your pupil is and the relative position of your pupil to these glints. And once you calibrate those movements to where the user should be looking on the screen, you can then start working out, right, if they move their eye to the top left, this is where on the screen that is. And then the final piece of the puzzle comes with tracking their head. So eye trackers have what's called a track box, which is it's a shape that extends from some way in front of them to some way further in front of them. And as long as your head's in that, it will track your head and compensate for where it thinks your eyes should be looking now.
Ah, interesting. So this makes me think of motion tracking when someone puts an actual dot or a blot of color on someone's face. When you think about, like the Lord of the Rings Gollum person, he's always filmed with these dots. Those are put on his face by a professional. These glints are sent out by the camera and then picked up again by the camera on the way back in. Yeah,
that's right. I suppose it's a very similar concept. It's just they're passively projected onto you rather than being stuck onto your face.
And you don't see them and you don't have to think about them. It's not like a laser, like the dot from a laser pointer.
No, it's not quite like that. You can see the light from the infrared. It glows a sort of soft red in most of these things, but no, infrared is generally invisible to our eyes. So yeah, you can't see it, but it can see you.
So then I assume you do some calibration, like you said, similar to a pen calibration?
Well, this is all actually handled by whichever tracker you've chosen to pair OptiKey with. So I want to draw the line of where my software starts and not try and claim credit for other people.
Oh,
but
that's a good point.
If you plug in the tracker, they'll typically have their own piece of software, and together they will run a calibration routine which shows a bunch of dots on the screen that move around. And what they do is they record your eye moving following those dots around. So let's say 9 points in the corners, somewhere in the middle. And it will have a picture of how your eye moves and how to translate that. So once it's got that, it just starts outputting a series of X and Y coordinates, which makes my job a lot easier because actually what I do is I just consume those. So I rely on the tracker and the tracker software to do the heavy lifting for me. And my job then becomes, well, how do you use that information in interesting ways? How do you present a user experience that allows people to do things that we would typically use the mouse and keyboard for?
Ah, interesting. Okay, so you're getting a stream of XYs from the SDK that sits on the top of one of the many cameras that you support, and that's their public SDK, .NET SDK, and you consume that.
Yeah, that's broadly it. And some trackers have got a .NET SDK that you can call straight into. Some have they stream over sockets, so you have to open up a socket and listen to these things and use a bit of regex or something to break them down again into their constituent pieces of data. Or every tracker has solved this problem in a different way, which is interesting but also frustrating and time consuming.
This episode of Hansel Minutes is brought to you by Braintree, code for easy online payments. If you're building a mobile app and you're searching for a simple payment solution, check out Braintree. The Braintree V.0 SDK makes it easy to offer multiple mobile payment types, so you can start accepting PayPal, Apple Pay, Bitcoin, Venmo, credit cards, and more, all with a single integration. One small snippet of code, and you're set up in less than 10 minutes. If you don't have time, you can give them a call. They'll even handle the integration for you and walk you through it. The SDK supports 7 languages: .NET, Node, Java, Perl, PHP, Python, and Ruby, elegant code, clear documentation. To learn more and for your first $50,000 in transactions fee-free, go to braintreepayments.com/Hanselman. That's braintreepayments.com/Hanselman. So thinking about the fact that you're doing it in WPF, there's kind of 2 ways. You could have either grabbed it as an event or created events, or you could do it kind of more pull-based, like using reactive extensions.
Which is the road that I went down. So when I started this project, RX wasn't released. So that was a huge problem that I had to solve anyway. And actually, I'm just going to caveat what I said with that might not be true at all. RX may have been released, but I was definitely not aware of it at that point.
So you became aware of it during the middle of the project?
Yeah, I did. At some point, I knew RX was out there. And can I plug someone?
Of course.
I actually went on a very good course by Lee Campbell. He did a course in London. He works for a company called Adaptive, and it was a 2-day professional course, and we all sat down in a classroom, and he taught us all sorts of cool things with RX. So that solidified what I tried to be teaching myself at that point.
Yeah, absolutely. That's Lee Ryan Campbell on Twitter, and he's got a great blog at leecampbell.blogspot.com, and he's been doing reactive extensions since 2010, as I recall.
Yep, he's the guy. He's the one who, when you start searching for things, he's either already answered the question on Stack Overflow or you end up on his Intro to RX blog.
That's brilliant. Isn't that wonderful how a community member didn't even realize they were helping you solve this problem while you were learning from them?
Yeah, and he's a very nice guy as well.
Yeah, that's great. So you have this stream of XYs, and you then bring that into your system. You've got a UI that looks a lot like the keyboard that you get with Windows, but it's your own imagination of that keyboard. You've added a lot of different things to it, and special icons and different glyphs to mean different things.
That's right, yeah. So I've been through maybe 3 different iterations of this, and how to solve the problem of generating speech in a natural and quick way. And I've kind of settled on a standard keyboard, and it's not optimal. I've had some feedback from people saying, well, why are you using a QWERTY layout? You know, there are much better ways of doing this. You could be putting the letters around in a circle, have some sort of radial dial. You could be using any number of alternate layouts which put the most frequently used letters more towards the center. And these are all perfectly legitimate pieces of feedback, but what I'm going for the whole time is stick with what people know. If it was me, and this has always been my test case as I've been designing this, what would I want to use? And I know a QWERTY keyboard pretty well, so that's what I wanted to use.
Interesting. That does bring up the question, though. If you wanted to use it because you had become disabled at a point in your life where you already knew the keyboard versus someone who might have always been disabled.
Yeah, and the idea, though, something that I put into the design is that the keyboard itself is just a thing. So there's something in there called the keyboard host, and it makes a decision about what keyboard to spit out. So it's based on what keyboard have you requested. So is it the letters?
Nice.
Is it numbers you want to see? Is it accented letters or characters? Whatever it is. So there's that context. There's what language are you currently configured to use? And then the last piece of the puzzle is there's a concept of keyboard sets, and that allowed you to say, well, I want a standard set of keyboards, or I want a simplified set of keyboards, and that's when I was going to go down a path of say, well, I want a radial keyboard, or I want something else. And then this keyboard host will make a decision and spit out the relevant one. And it's how we're starting to add support for French and German and some of the more complex non-Latin character-based languages. They've all got their own layouts and their own special characters. And so, it's an open source project. If you prefer a different layout, make it. It's very easy to plug in.
There's some really great YouTube videos and some wonderful animated GIFs where you are holding your hands in the air and you're showing us how this works. And as you look at the different keys, there's a pie chart that fills over time. And I can understand where you look at a key and you wait for a second for the pie chart to fill, and then that might be a level of confidence you have that you're looking at that button. But as you are typing a full sentence, I see you looking from key to key quite quickly, and sometimes the pie chart only fills halfway. What's going on there?
So the initial selection, if you were just doing letter by letter, like you say, it's filling a pie chart, and it's not just look at this key for X number of seconds and it will select. There's a few other things going on there, actually. Mm-hmm. So when you first push your attention to a letter, so let's say the letter H, and you want to type hello, there's what I call the lock-on period at the beginning. Mm-hmm. So that's a period of time before the key will react to you. So that allows you to sort of glance around the keyboard without every key suddenly starting a big animation and distracting you. So once you've cleared that period, which is only something like 50 milliseconds, so it's generally imperceptible, it then starts registering your progress. And when that hits 100, it will make the selection. But let's say you look away during that period of time. So you're halfway through selecting the letter H and something catches your eye, or you realize you want to look around and make sure this is what you want to be typing. So there's then a decay period on each selection. So it will stick around for a period of time. And this is all configurable as well. Mm-hmm. And this is built in because as I was playing with it over the generations of this code, you realize that things just feel a bit clunky and they feel a bit, not quite right, or they're too difficult to use. So anyway, that's what's going on with a single key selection. And it's a slow process. So you don't want to go HELLO. So as you identified, I do a complete selection on the H and then glance EL and then finish on a complete selection on the O. And in between, what I do is I capture everything that I look at, mm-hmm. and then I make a decision about which keys that I've touched are going to be significant. And it broadly speaking, will take the right letters, but it might end up with some extra letters that shouldn't be there, and it might end up with some letters that I've completely missed because I didn't give them enough attention as I was glancing around. And then I use an algorithm to match against a dictionary of known words.
So is this almost like a swipe keyboard, except for your eyes?
Yeah, exactly. And it was one of the first things that I thought when I started designing how this might work, because I had a swipe keyboard or a SwiftKey keyboard, or whichever one I was using. Mm-hmm. And I thought, well, this is excellent. This is very, very quick. But I knew at that point already that your eyes don't move like that generally. They jump in what are called saccades and fixations. So as you look around, if you look at your keyboard now and look HELO, you barely brush the keys in between. So as you go from the H to the E, you will not really look at the G, the F, the R. Mm-hmm. Your eye moves so fast as it makes that movement. So you actually end up with really nice HELO sort of hits, and it's much cleaner. Whereas when you're swiping with your finger, you've got constant pressure and everything you touch is potentially important. So those sort of keyboards have to make decisions in different ways.
So it's almost the edges, not the edges, the vertexes as you move from edge to, you move edges around. So you go H over to E, and then you immediately hit, you don't sit on E and hold there. You immediately do 180 degrees and you head back over to L. I assume you can detect that someone is bumped up against a point and then come back down, or how quickly can you do that? Is it the glance at E and then come right back down, or is it look at E and hold, and then come back down?
Well, it's adaptive. So it depends on how quickly you look at each key, and then it makes a decision that says, well, what was the average time of looking at a key? And so what do we decide is a threshold for this was a conscious look and this was something you just brushed up against by accident? But you've actually already solved most of the problem of how the on-screen keyboards do it with touch, because like you say, you do a 180 as you change direction. Mm-hmm. And I believe that's how a lot of those swipe style keyboards work. They look for velocity changes. So when you see that sort of strong acceleration or a dink in your path, something must have happened. You must have made a decision that you'd hit what you wanted.
Interesting. And how fast can you go? Are you going full speed when you are doing those GIFs and YouTubes, or are you going half speed?
No. So I knew that I had to get to a point of releasing the software, otherwise I was never going to get it out there. So this was at about 1:45 midnight on a work night. So I was tired, and I really didn't want to face recording this 10 times. So I set it to very, very modest settings, because A, I didn't want to screw it up and do it 10 times, and B, I wanted people to understand what they were looking at as well. So if I went too quickly, it would just be a blur of, well, that looked cool, but what was going on? So I put it somewhere in the middle. I've actually got a user in Germany who can use the system about 3 times faster than I can. So you can ramp it all the way up.
Wow, so you really can move fast if you need to.
Yeah, absolutely.
So this is not just about typing. It's also about clicking. You've got a great video where you show someone using Gmail, which I don't think is the most accessible of web-based emails, but there's a bit of zooming and a bit of careful clicking. Is it a little more difficult to use a mouse than it is to click around on a virtual keyboard?
Yes, I think so. I mean, its tolerance for making mistakes is lower because if you hold in a position for long enough, it will execute your action. So you have to be more precise. But then the algorithm around how it decides where you make your selection for mouse clicks is tailored differently from the algorithm around keyboard selections. Mm-hmm. So it's a little bit more tolerant. So it does stuff involving circles. So it will work out when you have locked on to an area where all of your points of interest, all of the places that I think you're looking, fall within a circle of a certain size. And then it will begin the selection and its tolerance will increase. So what you'll see is that as you see the mouse moving around on screen, the big sort of cursor animation that I do, you'll see it locks into a position and starts ticking on a selection. And the user can actually start straying a little bit with their eyes at that point so they can relax. Because up until that point, there's probably quite a bit of focus on them to hit exactly where they want. The sort of tolerance opens up and says, well, you've locked on somewhere, so I'm just going to let you relax, complete this selection. But if you didn't mean it to be there, you don't have to look too far and we can break this and try again.
So when people think about people with ALS, they usually come to Stephen Hawking, and he has a unique voice because it is the text-to-speech voice that I think, IBM used 20 or 30 years ago. And while there are ways to make his voice sound like his actual voice, and like including the fact that he's English and they've got him sounding like an American, people associate that voice with him. So he doesn't want to change it. But I understand that there's a thing called voice banking. So if someone's about to lose their voice or might have an eventuality to lose their voice, they can record themselves. How does that work?
So voice banking it's what you say. It's a process whereby you record yourself speaking a number of preset phrases and words. In one particular example, which is a company, again, I'd like to plug, called Model Talker. It's modeltalker.org. They currently provide a free service. So you record yourself reading 10 phrases, send it in. They'll tell you everything's good with your setup. And then you record 1,600 phrases, which takes hours and hours. But then what they do is they take that and they will synthesize your voice and give you back something that's compatible with Windows. I think it's called SAPI 5 text-to-speech. Mm-hmm. And then that becomes available for Windows to use or programs like OptiKey.
Oh, wow. So that is not only a free service, but what they're creating is a very standard thing, and it plugs into that drop-down that lets you pick the different voices Windows itself uses.
Exactly. So you can use your own voice with something like Windows Narrator, which would probably be weird because you'd be talking back to yourself the whole time. But if you want to use it with communication software, something that I've heard from a number of people with motor neuron disease is that your voice is very much akin to your identity. Mm-hmm. And losing your voice is a bigger deal than you or I might think it is. So yeah. It's very important, and services like this are just fantastic.
So kind of in closing, I'm curious, you built this and you worked for years and you worked on the train. At what point did you sit down with someone with motor neuron or ALS and showed it to them, that first time where they saw it and tried it?
I'm far too late in the process. If I was at work, I'd be sacking myself for not engaging the end users. I probably only put it in front of someone who was a prospective user about 6 months ago. And that was at a local hospital where I was put in touch with a guy who's an ex-software developer, so he knows what he's looking at. He was excited to play with this technology, and he's just been fantastic. So he's given me great feedback on things he likes about his current setup, that he likes better than my solution, things he doesn't like and things he likes, he'd like to see. And I've taken these things away and tried to build him his system. So up until that point, 3.5 years, it's been my system. And now it's sort of my system and Steve's system. And from the other feedback I'm getting from the wider community, people who know what they're looking at, he's really helped me along here.
Do you have a sense now how many people are using this? I mean, did you succeed? Is this something where you're getting an email every once in a while that says, this is it, you've changed everything?
Yeah. I wouldn't say I've succeeded because it's not finished. But yeah, I'm absolutely bowled over by the response. I'm receiving emails from people I got one yesterday where it was someone just saying, thank you, thank you, thank you. My mother hadn't spoken in months. We've built her this system. And, the first thing she did was, right, I'm really enjoying using this. And she kept hitting the speak button over and over again so she could hear herself talking. And that sort of feedback you don't get that in a day job, do you?
Yeah, that's fantastic. Let's also take a moment to thank some of the open source projects that you're using. So you've got RX and the reactive extensions underneath there. Mm-hmm. You've got MaApps, the Metro WPF library. You're using OptiKey. Mm-hmm. You got Prism, Log4net, the Common Service Locator. You've also got something called Mouse Keyboard Activity Monitor.
Oh, have I?
You're standing on the shoulders of giants.
No, absolutely. I couldn't have done this without years and years and years of other people's hard work, and I thank them all.
Yeah, it's fantastic stuff. So people can check this out at optikey.org, OPTIKEY.org, and they can interact with you, I assume, on Twitter or in the issues area. And I also, as a person who looks at a lot of open source, I have to give you a lot of credit for a really extraordinary wiki and bit of documentation. So often people throw these things up onto GitHub and say, here's some code. But I would aim to say that you've probably got as nice a wiki and as nice a group of documentation as any open source project I've ever seen.
Thank you very much. It's probably taken me as long as the actual software to do.
Well, it absolutely shows, and I hope that people who are listening, perhaps if you know someone who has ALS or motor neuron, that you spread the word, and also spread the word that Julius is not alone in this. He's got people helping out, but largely this is a one-man deal, and I'm sure that he would appreciate the help, the sponsorship in any way at all that you can. Thanks a lot for chatting with me today.
Thank you, Scott.
This has been another episode of Hansel Minutes, and we'll see you again next week.